Alright, so in this video, I'm going to solve an interesting exponential equation. So my equation is 100 to the power of x is equal to 400. And I want to find the value of x. So we see that x is going to be in between 1 and 2 because 100 to the power of 1 is 100 and 100 to the power of 2 is 10,000. So it's going to be more closer to 1 than it is 2, but it's going to be somewhere in the range of 1 and 2. So to solve this, what I'm going to be using is logarithms. So I'm going to first start by taking the log on both sides. So I get log 100 to the power of x is equal to log 400. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. In this case, I have log 100 to the power of x. I can move x to the front, so I get x times log 100 is equal to log 400. Now, I'm going to take the log of base 100. So, log base 100 of 100 is just 1. And log base 100 of 400, well, 400 is the same thing as 100 times 4. So I can rewrite this as log base 100 of 100 times 4, which is equal to log of 4 over log of 100. And I have 1 plus this because of this. So now log of 4 is the same thing as log of 2 squared. And log of 100 is the same thing as log of 10 squared. So I can move the 2 to the front and the 2 to the front over here. So I get x is equal to 1 plus 2 log 2 over 2 log 10. These two cancel out, so I get x is equal to 1 plus log 2 over log 10, which is equal to 0.301. So x is equal to 1.301. Alright, so in this video, I'm going to solve the equation 49 to the power of x is equal to x to the power of 14. So to solve this, I'm going to first start by taking the power of 1 over x on both sides. So I get 49 to the power of 1 over x is equal to x to the power of 14 to the power of 1 over x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So, by the way, this is 49 to the power of x to the power of 1 over x. So these two cancel out because x times 1 over x is just 1. So I get 49 is equal to x to the power of 14 to the power of x. Sorry, 1 over x. Now I'm going to take the power of 1 over 14 on both sides. So now, these two are going to cancel out, and I'm left with 49 to the power of 1 over 14 is equal to x to the power of 1 over x. And 49 I can rewrite as 7 squared. Now again, these two can multiply. So I get 7 to the power of 2 over 14 is equal to x to the power of 1 over x. And 2 over 14 is equal to 1 over 7. So I get 7 to the power of 1 over 7 is equal to x to the power of 1 over x. And notice how this is in the form number to the power of 1 over that same number is equal to x to the power of 1 over x, meaning x is that number, which is 7. And to check, I have 49 to the power of x is equal to x to the power of 14. So I have 49 to the power of 7 is equal to 7 to the power of 14. 49 is 7 squared, so I get 7 squared to the power of 7 is equal to 7 to the power of 14. And remember, these two multiply, and 2 times 7 is 14. So I get 7 to the power of 14 is equal to 7 to the power of 14. And because this is right, I know my solution is right. So please make sure to subscribe and leave a like. Thank you. All right, so in this video, I'm solving the equation 4 to the power of x plus 1 plus 4 to the power of 3 minus x is equal to 257. So I'm going to first start by using the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 4 to the power of x times 4 to the power of 1 plus 4 to the power of 3 times 4 to the power of negative x is equal to 257. Now from here, I'm going to multiply both sides by 4 to the power of x. So the 4 to the power of x distributes on my left-hand side, and I get 4 to the power of x squared times 4 plus 4 to the power of 3 times 4 to the power of x times 4 to the power of negative x, which is just 1. And this is equal to 257 times 4 to the power of x. Now I'm going to let the variable y equal 4 to the power of x. So I get y squared times 4, which is 4y squared, plus 4 to the power of 3, which is 64, is equal to 257y. And now if I subtract both sides by 257y, these two cancel out, and I get 4y squared minus 257y plus 64 is equal to 0. Now from here, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get y is equal to negative of negative 257 plus or minus the square root of negative 257 squared minus 4 times a, which is 4, times c, which is 64, all over 2a. So 2 times 4. Now, this turns into y equals 257, positive 257, plus or minus the square root of negative 257 squared, which, if I put in my calculator, is equal to 68,619 minus 16 times 64, which is 1,024, squared that all over 8. So now 68,619 minus 1,024 is 67,595. So I have the square root of 67,595 over 8. And the square root of 68,795, or sorry, 67,595 595 is 260. So I get y is equal to 257 plus or minus 260 over 8. So I get y is equal to 257 plus 260 over 8. And y is equal to 257 minus 260 over 8. So I get y is equal to 517 over 8, and y is equal to negative 3 over 8. So these are my two solutions for y. Now remember how we let y equal 4 to the power of x. So this means that 4 to the power of x is equal to 517 over 8, and 4 to the power of x is equal to negative 3 over 8. Well, you can't take the power of a positive number and make it equal negative, so there's no solution to this, meaning this is the only solution that we have. And to solve this, I'm going to take the log of both sides, so I get log 4 to the power of x is equal to log 517 over 8, meaning x is equal to log of 517 over 8 over log of 4. And to get the exact solution of this, I'm going to put this in my calculator. So the log of 517 over 8 is equal to 0.339, and log of 4 is equal to 0.602. So 0.339 divided by 0.602 is equal to 0.563. So this is my solution.